So in this video, we're going to talk about applied optimization. And in those problems, what we're looking at is taking what we've used with maximums and minimums and now applying it to some real-world situations. So let's look at the steps that we're going to use to solve applied optimization problems. The first thing that we're going to do is make sure that we carefully read the problem, and we want to determine what's been given to us and what we're trying to optimize. So you're looking for what is it you're trying to maximize or minimize. Second thing, if the problem is something that involves a geometric shape, try to draw a picture and label all the important parts of the picture. Sometimes those will be with numbers. Sometimes that may be in terms of a variable. The next thing we'll do is we're going to introduce our variables to the problem by listing any of our relations that we have as equations or algebraic expressions. So they may tell you have a given volume that you have to maintain and you want to minimize the surface area. Try to come up with some algebraic expressions or equations about that. Then you also need to identify what's unknown in the problem. What are you trying to maximize or minimize? Try to make an algebraic expression for that. Then what I want to do is write an equation for what it is that we want to have unknown. So if we're trying to maximize our volume, write an equation for the volume in terms of the variables in that problem. And you want to try to express that as a single variable or in terms of a function with a single variable, or if you have to, with two equations that have two different variables. Then the last thing is you're going to actually go through, take your derivatives so that you can get your critical points, and then test those and your endpoints. You'll use your first and second derivatives to help you identify and classify your critical points, and then make sure you answer the problem. If you're trying to maximize the volume, then make sure that you find the dimensions that might maximize the volume, or it may ask you for what is the maximum volume, so make sure at the end you've answered the question that they've asked.